So, good morning everyone. Today we are going to discuss the second introduction related to our project. So, first of all, we are going to just do a recap for our previous introduction. So, in the previous introduction, we talked we talked about the architectural description of our project. We talked about block B, block C, block A, and A prime, and so on. We also talked about the landscape of our project. We did a summary. We talked about the dynamic and static analysis, tributary and numerical method of analysis, also sizing of structure element, and we talked also about the shoring system of our project. We also talked about plaxes and manual analysis for the shoring system. We talked about the two sections for our shoring system, and so on. We checked the deflection. We talked about checking the deflection. We talked about our model in Etab, the plan related to our model block B and C, and so on. Serviceability checks concerning sway and drift. And now we are going to talk about the sizing of slab of our project. So the checks was done for two type of slabs only. So because in our project in real life we did a post tension system and a flat, okay, and the allowable deflection was related to L over 480, okay. So these are the slabs. Now this is the post tension slab in Adapt Builder, and this one after checking also, and this one in safe. Okay, the deflection also check. What I forgot also to mention is about the water tank. So we have a water tank inside our structure actually. So what we are going to do is we are going to model our water tank in Autodesk Robot Structure Analysis to check its soil pressure and its shear force and bending moment. And we are also to assume that we have a backfill with B equal 1 meter. Okay. And also we will do the analysis of free landing stair using Autodesk Robot Structure Analysis. The reason what we are not doing these element in Etab, because Etab does not have the ability for model this type of element. Okay, we can model this type of element also in SAP 2000, but robot it will be much more easier for us. Okay. Okay, so now we will move, we will see the normal stresses from our robot model, and also the longitudinal moment. We are going now to talk about the design and detailing. So the design and detailing, these are the material type also mentioned in the previous introduction. These material also were used in real life project. Okay, so what I'm going to explain is everything related to the real life execution of our project. Okay, so here the design of column C1. I will show you later on where C1 is located, and these are the typical connections of concrete columns. These are the wall reinforcement, the shear wall, core wall, and here we have a ground floor first base and second base. So these are the connection between a wall, because we have a retaining wall actually, and after the first base our wall dimensions will be smaller or lesser, so we are going to do a special connection between these two. Okay, so we have a retaining wall also, we have a water tank, and these are the detailing steel for our water tank. Okay, we have a free landing also. We have a flat slab, we have a radial, we have a post tension slab also. These are the distribution of our tendon and the height of our tendon. Okay, so these are the typical slab edge detail at live end and the typical slab edge detail at dead end. Why? Because at live end we must reinforce our live end, because we have a high jacking force also, and also at the dead end just to avoid any failure in concrete section, okay, during the casting process. Okay, so this model explain why we need reinforcement actually, in the free this is in the end zone design. Okay, so here we are going to talk about post tension versus flat slab. So actually the main difference that we are to mention here is the cost difference between these two slabs. It is something related to the cost rate analysis. Okay, so we will see how much we will save when we move from flat slab to post tension slab, and these costs are taken from our real life. Okay, so this is the flat slab reinforcement. Okay, and we have the PT reinforcement also. We can see that the total cost of PT slab is $48,423. Okay, and this is $50,189. So we can just check the difference between these two. We can check that for each slab we are going to save $2,465. Okay, so if we have 10 slab we are going to save approximately $25,000. Okay, so now we are going to talk about block A and A prime steel structures. So these two structures are only executed as a steel structure because we have shopping center inside them. Okay, so we have to check also the non-composite versus the composite behavior of steel. Okay, so we have deeper steel section here selected, and we have cost of shear stud here, $2 per stud. Okay, but we have here a note: for girder with a span less than 2 meter, shear connectors may cost more than saving in steel girder. So those non-composite construction is preferable. Okay, so when we have a girder less than 12 meter, it's more preservative to go just for saving money actually to go to non-composite system. Okay, so here we have detailing of rigid connection between the beam and the column. Here we have a circular steel column, and we have here a beam which is HEA 400. We have a connection. This is the stud or bolt. Here we have the hinge connection. The difference, we can check the difference between rigid, which is actually fixed connection here. Okay, and here we have what hinged. Okay, here we have what hinged with this means what we have X and Y forces only reaction as a reaction. Here we have moment in addition to X and Y. Okay, here we have the column base connection. We have connection between the column and this is its base. We have like this. Okay, here we are going to discuss the foundation, and we talked about the foundation in the previous introduction actually, and I told you that we are going to use the raft foundation. Okay, is controlled, the thickness of raft foundation is controlled by branching shear. So I mentioned also the thickness of the raft for block B and C, sorry, and I told you for block B and C we are going to use the raft foundation combined with pile, and in block A and A prime we are going to use single footing. Okay, so here what we are going to see, we are going to check also using Allpile and safe and manual calculation also to calculate the required length for pile. Here we have more preservation actually when we are going to go to manual analysis, but we are going to take this length because here we are going to take more safety factors. Okay, in just for money purpose actually, just in order to save more money, we can just use in this section, okay, pipe length of L equal 30 meter. Okay, so here and in the green area actually we can use this 16 meter. We can check this if it's okay, safe or not, using also the safe program. Okay, and we will see that in this area we can just move with a pile of 13 meter. So we have a steel mesh in radial direction. This is the radial direction. Okay, so we have a steel mesh in this direction, which is called tangential direction. Here we have additional steel in tangential direction. Also, we are going to detail all this plan. Okay, so we are going also to discuss some point related to the PT slab execution. Okay, so how to prepare our site to for PT execution, how to do the right detailing for punching shear. We must use actually stud rail, but in case we didn't find stud rail, we can move to this type of connection or detailing for punching shear. Okay, so here we are also going to explain the execution of piles and a difference between these two type of piles. So for the time being, this is all for the second introduction. So in the next lesson, actually, we are going to move forward with modeling. Actually, we are going to use the Etabs and other software in order to modeling. Just I need to show you something related to our project. Actually, here these are the plan. So this is the plan of a block C. Okay, as I said, this is a real project. So this plan represent the tendon. Okay, here because we have PT slab, we will check later on. And we have also for block C, let's say this is the water tank in a block C, and this is for block A, the stairs. Okay, here we have block C, block C also, and I will going to show you block B. Now this is a block B. So this is a block B. Actually, also the PT system for block B, we can check. We have PT in two direction. Okay, so and we have some picture related to our project also during the execution phase. And this is block A and A prime. This is block B and the block C. Okay, so this is during the end phase, and this is during the final phase. Okay, here we have let's say the interior of our project, interior design. Okay, so that's all for today.